Hi everyone. The next concept is runtime polymorphism, and it is also called as a dynamic method dispatch. So first of all, you have to understand what is a polymorphism. So in the early classes of Java subject, you know what is polymorphism. So just to recall it, so polymorphism is basically one of the basic object oriented program principle. Okay, so what is polymorphism? uh, Polymorphism is nothing but so performing a single action in different ways. Okay, so performing single action in different ways. So actually the polymorphism is a word which is actually derived from the Greek words are two. They are poly and mops. So what is meant by poly is nothing but many, and for mops is nothing but forms. So totally a polymorphism means so many forms. So one can exhibit many forms. The real time example for this polymorphism, you only. Okay, so in the college you are act like a student. In your home you may be a son, brother, a sister, daughter. Okay, so like this you are playing so many roles. A single person playing many roles. So that is nothing but a polymorphism in Java. Okay, so there are two types of polymorphisms are there. They are compile time polymorphism, whereas the second one is the runtime polymorphism. So what is so we have to perform this polymorphism in Java either by method overloading or method overriding. So by using method overloading or method overriding concept, so we can perform polymorphism. It may be compile time or runtime. There is no matter of type, but actually the polymorphism can be done in Java with the help of either method overloading or method overriding. Okay, so both we completed, right? So if you want to overload a static method in Java, so we cannot override static method. That is a very important. So we cannot override a static method, but we can overload a static method. There is a difference between overload and override. Overload means except return type, signature should differ. Okay, name of the method only same, but the order of parameters, number of parameters, type of parameters all differ in the overloading. We won't consider return type. When name of the method only same, order, number and type of parameters are differ in the method overloading. Okay, but when comes to the method overriding, overriding is the concept where name of the return type, so okay, leave the return type, name of the method and order of the parameters, number of parameters and type of parameters are all same. Okay, there is no difference in the name methods in the method overriding, but there is a difference in the methods of the method overloading. Okay, see the videos, then you will better understand method overloading and method overriding. So we cannot overload a static method, override a static method, but we can overload a static method. If you overload a static method, then that is an example of a compile time polymorphism. Okay, but now the concept is runtime polymorphism. Let's look at it. Runtime polymorphism or dynamic method dispatch. So what is a runtime polymorphism or a dynamic method dispatch? Is nothing but a process in which a call to an overridden method. Okay, if it is a runtime polymorphism means you just go with the overriding concept only. Okay, don't bring the overloading concept here, just you look at the only overriding. Okay, so overriding means name of the method, order of the parameters, type of the parameters and number of parameters all are same. Okay, so when comes to the process of calling a overridden method is resolved at runtime rather than compile time. Okay, so generally calling a method can be defined either compile time or runtime. Compile or runtime means before executing a program. So then compile time, that is called as a compiling of a program, right? So calling a overridden method can be decided at runtime, then that is called as a runtime polymorphism simply. So in this process, a overridden method is called through a reference variable. What is a reference variable? We already know while creating an object. So how to create an object in general? So name of the class, name of the object equal to new name of the class. This is the how we can create an object. So without using a new keyword, a is simply called as a reference variable. Okay, until you specify a new keyword, then that this object is called as a reference variable only. Okay, if you specify new keyword, which means you are allocating a memory, you are making that reference variable as a object. If you see the normal variables declaration, data type, name of the variable. Okay, so half of the part is similar to the declaring primitive data types. So that's why it is called, if here it is a class type. Okay, not like a int, float, primitive data types, it is a class type. Okay, so that's why a is called as a reference variable. Okay, until you specify new keyword, it is called as only reference variable. After you specifying a node executing, memory is allocating, then a is called as a object. Okay, so in this process, an overridden method is called through a reference variable of a superclass. Okay, we know the concept of inheritance, superclass and subclass. So reference variable of a superclass will call the overridden method. We'll see. Just understand the text, then you will understand what is there by example. So the determination of the method, which method? Overridden method. So which overridden method has to call can be based on the object being referenced back to a reference variable. Okay, so we have a superclass reference variable, we have to call overridden method. How it is decidable? How it is means, so based on the object we referenced to that reference variable. Okay, so calling a overridden method at runtime by using the reference variable of a superclass, then that is called as a runtime polymorphism. We'll see the example, then you will understand. Okay, so before that you have to understand what is upcasting. Okay, so a simple concept here, upcasting. Okay, just leave runtime polymorphism or polymorphism dynamic method of all you just leave and just simply listen what is upcasting. If the reference variable of a parent class refers to the object of a child class, it is known as a upcasting. Okay, so see here, diagrammatically, reference variable of parent class, object of a child class. So go with the inheritance. Class A we have, class B we have, second class, it extends A. So then in between class A and class B we presenting is a relationship. Extends is a keyword used to represent inheritance, that is actually is A. B is a class of is a type of A. Okay, so when we go with examples like okay, SBI is a bank, ICICI is a bank, Axis is a bank. Okay, so that means inheritance is nothing but is a relationship. So B is a type. So in between A and B we are presenting inheritance. So now we have a compulsory method that is required always, public static void main. There we are try to create a variable. How to create a variable? Name of the, so it is inheritance means creating subclass object is enough. Okay, but there is no condition, means no need of creating any superclass object. Okay, so creating while discussing object, I just mentioned that creating, if it is an inheritance, creating an object for subclass is enough, that is enough, which doesn't mean, so there is no possibility of creating object for the superclass. I didn't specify like that. Okay, so creating an object for superclass and subclass both are possible, but for accessing superclass data also, so creating an object for subclass is enough. Before inheritance, what we did, creating object for individual classes and calling the members of a class by using that object is happening. But when comes to the inheritance, so no need of creating any object for the superclass, no need to create. Okay, so we cannot create, I didn't tell like that. So by creating an object for B, we can call what is there in A. Okay, that is possible with the extents. Now the thing is, so I can create an object for the A. So how it is? So general a name of the class and a reference variable object equal to new equal to a. If you specify a here, then that is a is an object for the a class. Okay, so what I am trying to do is I am just creating a reference variable to a class. Okay, so and then I am assigning, so new b, new is for creating an object. What kind of an what to whom I am creating an object? For b. Okay, so new b is nothing but a creating an object to b class. So I'm assigning this to, if you observe the anonymous class object creation, these all happening over there. Okay, so I am trying to create an object for b class. B is a subclass, okay, child class, and I am assigning this object to the reference variable of a. Okay, if here also we specify a, means simply we are creating an object for a. Okay, but what we did here, I am creating a reference variable, I am allocating b object to that one. Okay, so this concept is called as a upcasting. So reference variable of a parent class. Who is parent class here? A. This is a reference variable, not an object. Okay, if you specify a here, then a become an object, but what we did is we are just creating a reference variable like a normal variable, int a, float b, like that. Here a is a class, a small a is a object. Okay, so parent class refers to the object of a child class. It is known as upcasting. Okay, so now come with the runtime polymorphism. So we are creating two classes, bike and splendor, where splendor extends the bike. Okay, and here we have a methods. In bike we have a run method, and here in the splendor also run method. What it mean? Method overriding. Okay, so we are overriding run method. So we are calling the run method by the reference variable of parent class. Okay, so if you want to call the method of a subclass, you can also use directly, you can call. Okay, so by creating an object for a splendor, you can call it, but we have other options also, that is nothing but runtime polymorphism. See, so always you have a doubt that already we have a possibility of calling this method directly. Now why we need runtime polymorphism? That means here lot of options are there for you. You can use wherever you want. Okay, so if you want to go with the static definition, int a equal to 10. Okay, otherwise you can insert the data dynamically, that is a scan of person d, so reading of data. Okay, there are possibilities. So don't think why do we have, why this kind of things are, don't think like that. Okay, so there are facilities are there, whenever you want you can use them. Okay, so directly calling this method is possible, and also so in this way also you can use them. Okay, call them. So we are calling the run method by the reference variable of a parent class, since it refers to the subclass object and the subclass method overrides the parent class method. The subclass method is invoked at runtime. So since the method invocation is determined by the JVM, not compiler. In general, the method invocation is done by the compiler if it is a compile time, but it is a runtime, then that is decided by the determined by the JVM. So this entire concept is called as a runtime polymorphism. See the example. We have a class bikes and we have another class splendor extends bike. So bike is a superclass, splendor is a subclass. Both have a methods with the same name, run. So tell me, is this method overriding or method overloading? This is method overriding only. So why? Because method overloading means at least they differ at one point. It may be type of parameters, or maybe order of parameters, or number of parameters, but here we don't have any difference between these two. That is nothing but a method overriding. So yeah, here it is a running bike, here running safely with a 60 kilometers, okay, kilometer per hour. Okay, then we have a compulsory method where the execution starts, public static void main. Okay, we'll see here bike is the superclass, and this is a reference variable equal to new and splendor. Okay, so what we are doing here, we are assigning the subclass object to the superclass reference variable. Okay, so this is actually upcasting. Upcasting is a part of runtime polymorphism. Okay, so then b dot run. B dot run. So what is trying to do is, so if we call a b dot run, what is a b here in general? B is a reference variable of superclass. Also we need to call the superclass method. So like that we can think. But the thing is, which object we are allocated for the b? Subclass. Okay, so that means we are calling the subclass method. So the output is defined like running safely with 60 km. Okay, so understand the runtime polymorphism, you have to understand two concepts. One is inheritance, the second one is the overriding. If you understand those two concepts, it is very easy. Okay, so anyway, by simply calling a overridden method, how to call? By using the superclass reference variable and subclass object. We are assigning subclass object to that superclass reference variable. By that reference variable we can call the subclass method. Okay, so this is called as a runtime polymorphism, only possible at overridden concept. Okay, overridden is required, is inheritance is required, then calling the subclass method with the superclass reference variable by assigning subclass object. This entire thing is called as a runtime polymorphism. Okay, so go with the real time example. Already we saw this example in the overridden concept. Okay, so banks are very much useful in nowadays. Okay, different banks are there. Different banks have different interest rates. Okay, so to implement this we have to go with the method overriding. Okay, so class bank, SBI extends bank, ICICI extends bank, and class Axis extends bank. Okay, that means superclass this one, and all these are subclasses having the same, see here, return type same, method name same, and there is parameters also same, no parameters also same. Okay, if they differ in parameters, order, type, and sequence, order, okay, order, number, type, then that is called as a method overloading. But here we are presenting only method overriding. So interest written by the bank is 0, but if it is a SBI 8.4, like ICICI 7.3, and Axis it is 9.7. Okay, when comes to the class, so main method we are presenting in different class. Okay, so class test polymorphism, main method. So bank B, bank, what is a bank here? Superclass. I am creating a reference variable for B. First time I am assigning the subclass SBI object, second time I am assigning the subclass ICICI object, third time I am assigning the Axis Bank object. Okay, so what is happening here? For the superclass reference variable I am assigning the subclass objects. Okay, so to call the subclass methods, so here where the values here, so 8.4, 7.2 in the subclass methods, so we got an output like this also. Okay, what is happening? To call the subclass methods, overridden methods, we are taking the help of superclass reference variable. Okay, so this is all actually. So now while executing, the JVM will decide so which method you have to call. First you have to call the SBI method get rate of interest. Second, it will decide ICICI Bank method. Next, it will decide Axis Bank method. Okay, so what is happening here? We are calling the overridden methods of subclasses with the help of superclass reference variable by assigning subclass objects. This is called as a runtime polymorphism. Okay, so runtime polymorphism with a data member. Okay, so till now what we discussed is, so we are calling the overridden methods. If you see here, so is a process in which a call to a overridden method. Okay, so here also we call overridden method, here we can call overridden method, here also we can call the overridden methods. Okay, but uh, not only we can have overridden method, sometimes we have data members also. Okay, not only methods, and also we have variables also. Okay, so now the question is it possible to call variables also in the runtime? The answer is no. Okay, so a method is overridden, not the data member. Remember this, we can overridden the methods only, not the data members. If the method is overridden, okay, we can use the runtime polymorphism, call them by using runtime polymorphism. But if it is not overridden, that is data member is not overridden, means we cannot it cannot be possible. Okay, so runtime polymorphism can't be achieved by data members, it can be achieved only through the methods. So in coming example, so we have a classes, and we have a data member speed limit and means variable. We are accessing the data member by the reference variable of the parent class, which refers to the subclass object. Same how we call these methods of subclass. Okay, like this subclass methods. Like that only we are trying to call the members. Data members means variables. Since we are accessing the data member which is not overridden, hence it will access the data member of the parent class always. Okay, class bike, we have a int speed limit 90, and a class Honda 3 we have extends bike, means it is a superclass, it is a subclass, int speed limit equal to 150. Okay, so here the thing is data type same, name of the variable same, so which does not mean that it is overridden. Okay, so it for the variable overridden is not possible, for the method it is possible. Okay, here we have two values 90 and 150, the public static void main compulsory method. So what we did here, bike object equal to, bike means superclass, object we are creating equal to new Honda 3, that means subclass object we are creating, system dot out obj nothing but a superclass reference variable. Okay, so previously what is happening, by using the superclass reference variable, when you call the method, so based on this definition which object you are assigning, based on that definition that method is calling. But here tell me, so if you use like this, then so it will give, you can think like that, it will give subclass speed limit value, that is 150, but is actually not, we won't get that output, we get only 90 value. Okay, so why? Because so for the data member we cannot perform the overridden. If it is not possible to do the overridden, then there is no concept of runtime polymorphism, it will call only the superclass member. Okay, not the subclass member. Okay, understand? So that's all. Thank you.